This conference will now be recorded.
The screen is visible to all. Hello.
Yes, yes, sir. Yes, sir.
Okay. So now I will try to explain for induction machine by taking universal torque expression. Why torque control is very complex in AC drives by taking this universal torque expression. Universal torque expression I will try to. So Zs, Zr, sin delta. In case of induction machine, so by using this torque expression, we can decide the how many number of state variables are involved in the torque expression we can identify. That is the first step. So with respect to stator side, there are three state variables are there. A phase stator flux, B phase stator flux, C phase stator flux. With respect to rotor side, again three state variables are involved in the Zr. Because of interaction of this A phase, B phase, C phase, you will get resultant stator flux. Similarly for rotor side also, A phase, B phase, C phase, A phase, B phase, C phase, rotor flux interaction, you will get resultant rotor flux. So finally, 3 plus 3 plus 1. Next, one more important thing is in case of induction machine, is delta load angle, it is not a constant. But in case of DC machine, delta is always 90 degree because of commutation action. At any instant of the time, rotor flux is always in phase with press axis. Similarly, stator flux is always in phase with pole axis. Delta always 90 degree because of commutation action. But in case of induction machine, this delta, it will vary based on the operating condition. If there is any change in the voltage, or if there is any change in the frequency, or if there is any change in the speed, this delta will regulate. That's why it is not a constant. This one also you need to treat it as a state variable. So one total, there are 7 state variables are involved in the torque expression. Now you can think, if you want to control the torque in case of induction machine, there are 7 feedback, 7 state variable informations are required. Without taking the 7 state variable information with respect to torque controller, very difficult to control. Next, one more thing is, it is a nonlinear equation. Right, compared to first order equation, now you can, if you take induction machine, so torque control is very complex. There are 7 state variables are involved in the torque expression. Torque control is very difficult, right? More number of feedbacks are required, right? Dynamic performance is very poor. These are all the challenges in induction machine. How we can overcome these challenges? These are all the main challenges in AC drives. In order to eliminate the non-linearity, to take induction machine, synchronous machine, or permanent magnet synchronous machine. Here, if you take torque expression, all are in higher order condition. Nothing but all are nonlinear condition. That's why here your job is you need to take care about the nonlinear component in the torque expression. Next, more number of state variables are involved in the torque expression. That's why control complexity will increases. Next, at the same time, if control complexity increases, burden on the processor increases. At the same time, steady state performance will degrade. That's why you need to put more concentration on the steady state also. These are all the main challenges in AC drives, particularly. Why? Because these challenges we can decide based on the torque expression, whether torque is linear or non-linear. We can decide. Basically, AC machines are in non-linear condition, higher order condition, dynamic response is very poor. But why people are motivating towards vehicle application? AC drives. Main reason is AC drives physically very strong. It will occupy very less space, more reliable, less cost, maintenance is zero. These are all so many features are highlighting towards AC drives, motivating towards AC drives. Now, how we can overcome these challenges? So by using, this is the first method, understanding the machine behavior. This is very important point with respect to scholar. As a scholar, if you want to control the AC drive or any system, not only AC drive, first step is you need to understand the machine behavior, how machine is behaving. Particularly in classroom, what we are doing as a teacher, before going to control the student, first step is you have to understand. As a teacher, you need to understand how students are behaving. Student characteristics you have to extract. Without extracting the student characteristics, very difficult to control, very difficult to uh, learn the subject, very difficult to teach the subject, right? That's why. So how we can extract the characteristics of the particular system? In order to extract or in order to understand the behavior of the system, generally here they are adopting mathematical technique. By using mathematical technique, they can develop the model for the system. Modeling.
Excuse me, sir.
Modeling. Hello, madam.
Excuse me, sir. Sir,
Ah,
all are muted, sir, but we are getting some disturbances. Any work is going on, sir, there?
just 1 minute, madam. 1 minute.
Okay, sir.
Hello, hello, hello.
Yes, sir. Yes, sir.
Madam, can you wait just 2 minutes, madam? They are
Okay, sir. Okay,
leaving. Just 2 minutes, madam. After that, I will.
okay, sir. Okay. Dear participants, in between you can fill the session 1 feedback link. Feedback link is in chat box, sir. Hello everyone, please fill the session 1 feedback in between. Feedback link is provided in chat box.
Hello.
Yes, sir.
Yeah. Sorry for interrupt.
No problem, sir.
Uh,
Please continue, sir.
So, in order to overcome the challenges, in order to the main aim of this slide is by using this slide, how they are taking care about this torque, how they are trying to control the torque, particularly for AC drives. So, in order to control the torque, particularly for AC drives, torque is in complex form. It is in higher order condition. More number of state variables are involved in the torque expression, right? So, how they will handle it? Why? Because torque is one of the control variable in electrical drive system. So you need to put more concentration on the torque control. While controlling the torque for the AC machines, it is naturally torque is in higher order condition. That's why here, in order to control the torque, you need to take care about the nonlinear component. Control complexity, you have to take care. That's why in order to reduce the complexity with respect to controller, here you need to understand how machine is behaving mathematically. You need to understand, that is called modeling. The main aim of modeling subject is by using this modeling concept, we can develop the mathematical expressions for the particular system. Once you're having mathematical expressions for a particular system, we can easily extract the characteristics. Once you have a characteristics of the particular system, here after that we can analyze and we can identify the application. That is the strength, that is the beauty of this mathematical techniques, right? After that, one more important thing is you need to apply transformation techniques. So by using this transformation technique with respect to controller, we can reduce the complexity. Many of the scholars, they are thinking about by using this transformation technique, we can reduce the complexity in other we can reduce the complexity while estimating, not for estimation. Please try to understand. The main aim of this transformation technique, three-phase to two-phase, two-phase to two-phase transformation technique, main aim is reduce the complexity with respect to what is the reference? With respect to control circuit. With respect to control circuit, they are trying to adopt transformation techniques in AC drives. After that, your job is you need to select suitable power electronic model. By choosing suitable power electronic model, we can change the drive characteristics based on the application requirement. That is the that is the main strength of power electronic model. By choosing suitable power electronic model, we can change at the same time we can improve the characteristics of the drive. Without taking power electronic model, AC drives generally they were using constant speed application. Before invention of power electronic model, no one is using AC drives in variable speed drives application. AC drives they were using for only constant speed application. But after invention of this power electronic model, they are trying to adopt this AC drives for variable speed drives application. Next, after that, this is the important point. By selecting the vector control technique, we can eliminate the nonlinear component in the machine dynamic equation. What is the advantage? If you are able to eliminate the nonlinear component in machine dynamic equation, main advantage is we can improve the torque profile. We can control the torque instantaneously. In order to control the torque instantaneously, basically with respect to control circuit, torque should be in first order. By using this vector control technique with respect to controller, we can bring the torque expression from higher order to lower order. How we can bring the torque expression from higher order to lower order in today's session by taking field orientation control scheme, I will try to explain. Right? This was the significance of transformation technique. By using this slide, we can understand what is the application of transformation technique, where it is useful. Generally, this transformation technique in power quality issues in grid connected inverters, electric drives, they are adopting this transformation technique, right? While using this transformation technique, there are two concepts are there. One is magnitude invariant, another one is power invariant. Generally, 2/3 factor they are using for net power invariant, square root of 2/3 they are using for magnitude invariant. Generally 2/3 they are using for grid connected inverters application. Generally for power system application they are adopting they will take 2/3 multiplication factor. before the transformation matrix. Transformation matrix, they will multiply with square root of 2 by 3 for drives application. Generally for drives application, they are using this technique, magnitude invariant concept. For power system application, they are using 2 by 3 multiplication factor. Right? Generally, these three techniques are so popular in literature: Clark transformation, Park transformation, cross transformation. Next, one more important thing is here. This is the natural. This is called natural system. Natural system is always in three phase. This for the transformation. After applying the transformation technique to the natural variables, they will take natural variables, natural signals, and they will convert it to these transformations. After applying the Clark transformation technique, these three-phase variables will convert it to two-phase variables. Next, again, these two-phase AC variables, we can convert it to two-phase DC variables by using Park transformation. The main object of Clark is it will convert three-phase to two-phase AC. Before converting, signal nature is AC. After converting, also nature is variable, nature is AC. But if you take Park transformation, by using Park transformation, we can convert two-phase AC to two-phase DC. Finally, the output variables are in DC nature. This one, practically, while designing the PA controller, they are using these two-phase DC variables. By using these two-phase DC variables, we can design the KP and K values very easy. Compared to AC signals, here for DC signals, we can easily design the KP and K values. Why? Because here, if signals are variables nature, variable signals are in DC nature, advantage is you need to put more concentration on only magnitude. If it is in DC, otherwise, if it is in AC nature, then you need to put more concentration in magnitude as well as phase. It is very difficult. That's why I'm audible. I'm audible to you, participants.
Yes, sir. Yes, sir.
Yeah, yeah.
Yes, sir. Yes,
So,
sir. Audible,
yeah,
sir.
yeah, okay, fine. That's why here most of the cases with respect to controller, finally they will sense by using current sensors, by using voltage sensors, they will sense the three-phase natural signals, they will sense. After that, by using this mathematical technique, this transformation technique is nothing but it is completely deals with mathematics only. By using mathematical techniques, by using transformation technique, we can convert three-phase to two-phase DC. So here, while converting these signals from three-phase to two-phase AC or two-phase AC to DC, many of the scholars, they are getting doubt. What about actual system characteristics? Please try to understand, actual system characteristics will not lose whatever information. Let us assume that take three-phase induction machine, right? Let us assume that these three signals are three-phase applied voltage to the induction machine. Then whenever you apply the three-phase balance voltage to the three-phase induction machine, you will get speed torque characteristics of the induction machine like this. Torque speed profile. Whatever torque speed profile you are getting by using three-phase balance voltages, same torque speed characteristics you will get without changing amplitude, without changing position. You will get same signal. Whatever signal you are getting by using three-phase natural variable, same torque speed profile you will get by taking two-phase AC variable. At the same time, by taking two-phase DC also, you will get same characteristic, torque speed. Finally, here, speed torque profile will not vary. Whatever, so here what we are doing, same information, torque speed profile, we are extracting with less number of variables. Here also, we are trying to extract the torque speed profile with less number of variables with zero frequency signals. That is the beauty. That is the main aim of transformation technique. By using transformation technique, we can extract, we can carry the same information. This one, torque speed profile, if you want to extract from the three-phase variables, you need to take more number of, it requires more variables. If you take, after applying Clark transformation technique, only two-phase variables are involved in the torque expression. Yeah, again, if you apply Park transformation, less zero frequency signals are involved in the torque expression. So finally, in all cases, same torque profile you will get. There is no change in the information. Final information In all cases, it is carrying the information without losing the information with less number of control variables. It is trying to execute. It is trying to give the same information to the controller. That is the beauty of this transformation technique. What is the application of this cross transformation? By using cross transformation technique, directly we can convert it from three-phase to two-phase DC. Three-phase AC to two-phase DC we can convert by using cross transformation technique. Next, one more important thing is if you observe these waveforms carefully, so in three-phase natural reference plane, what is happening whenever you apply this three-phase reference plane, the resultant MMF, this rotating vector is there, green one, light green one. So this is the rotating MMF. So even if you take two-phase system also, the net MMF is rotating. MMF is rotating. In case of two-phase DC also, net MMF is rotating. Finally, there is no change in air gap MMF. In all cases, air gap MMF is rotating. Rotating MMF is required for any dynamic systems. Right? Next, before discussing some important key points, I want to ask some fundamental questions. Right, to the participants. Almost 1 hour session is over. Here remaining off session, we'll try to make more effectively based on these fundamentals. Can I ask one question to the participants? Now, please tell me how we can decide, how we can understand the static EMF and dynamic EMF with respect to machine parameters. Static EMF and dynamic EMF. How we can differentiate?
If it is rotational part, we will get an induced
No.
EMF. Yeah.
No. Listen my question very carefully. How we can differentiate the static EMF as well as dynamic EMF with respect to machine parameter? I'm telling machine parameter in terms of how we can differentiate. So to understand this concept, you need to take Faraday's law. According to Faraday's law, here the strength of the induced EMF is directly proportional to L, otherwise directly proportional to d pi by dt. From this equation, E equal to d by dt of Li. From this equation, L di by dt plus I into dl by dt. So there are two components are there. What is the name of this first component? Is it static EMF or dynamic EMF?
Dynamic EMF, sir.
This one.
Rate of change of current.
That's what I'm telling. How we can differentiate. Now already I have given hint. Already mathematical expression is there. Now think.
This L into d by dt self-induced EMF. The second one
Is
is
it static or dynamic?
it's static, sir. It is L is static. Yeah, L is fixed.
Yeah.
This
Static.
one?
Second one is inductance is
That's
varying,
one.
so that one is dynamically varying.
Dynamic,
So
right,
please
sir.
try to understand. By using this equation, we can conclude that here, if there is any change in the current with respect to time, we can conclude that if condition is, what is the condition here? L is constant and L
Constant.
will not vary with respect to time. Winding inductance, particularly, what is the best example? If you take transformer, in case of transformer, inductance, even once you take your transformer, leakage inductance, magnetizing inductance, self mutual inductance will not vary with respect to time. That's why you will get only static EMF. Particularly competitive examination or any other interviews, they will ask how we can differentiate the static EMF and dynamic EMF with respect to mission parameter. Mission parameter nothing but based on the electrical, particularly electrical parameter. As electrical scholar, we need to highlight this difference with respect to electrical parameter, nothing but inductance. If inductance is constant with respect to time, you will get only transformer EMF. You will get only static EMF. If there is any change in inductance with respect to time, then you will get dynamic EMF. Generally, based on modeling and analysis of the electrical machine subject, it is completely based with this equation. By using this equation, we can understand whether it is transformer, whether it is This is called dynamic EMF. Dynamic EMFs are classified into so many parts. Eddy current, torque. Because of this dynamic EMF, you will get twisting force, right? Twisting forces are classified into so many parts. One is reluctance torque, reaction torque, eddy current, hysteresis torque, right? Based on the structure of the machine, we can understand whether it is producing reluctance torque, whether it is producing electromagnetic torque. We can decide, right? So here, by using this equation, we can differentiate the static EMF as well as dynamic EMF. You forget about static EMF. Dynamic EMF, based on the I into dl by dt component, we can produce mechanical power. In order to generate the mechanical power, winding inductance must be varied with respect to time. This is the fundamental concept for electrical machine subject. Any machine, whether it is DC machine or AC machine, whether it is single phase or multi-phase, right? For any machine, here, if you want to convert the energy from one form to another form, it requires rate of change of inductance with respect to time. Inductance should be varied with respect to time. Then only you will get energy conversion. Otherwise, there is no energy conversion. Only energy transform will happen. In case of what is happening in transformer, only energy is transferring from one circuit to another circuit without transforming, right? Same thing here. But in case of dynamic machines, if you want to change the energy, if you want to convert the energy from one form to another form, electrical to mechanical, right? If you want to convert inductance, you need to take care. Inductance must vary with respect to time. That's why if it is cylindrical machine, forcefully, here they will arrange the winding on the rotor side and they will rotate the rotor. Why they are rotating? Why rotor is rotating? If rotor is rotating, mutual inductance will vary. In some cases, mutual inductance will vary. In some machines, self-inductance will vary. Right? Machine to it is completely whether mutual inductance is vary or self-inductance is vary. We can decide based on the structure of the armature core as well as structure of the stator core. Right? Both without knowing the structure of the stator core, without knowing the structure of the rotor core, we cannot decide whether mutual inductance is vary or self-inductance is vary. You should have idea regarding the how whether rotor is salient pole or whether rotor is cylindrical. Stator poles are projected or salient. By using this concept, we can decide the nature of the torque produced by the machine. Right? This all are the fundamental concepts. Based on this fundamental concept, we can easily control. Next, one more important thing is what is the beauty? What is the main advantage of the transformation technique? Already I explained. By using three-phase control variables or two-phase control variables, here if you take net power invariant concept, whatever power you are getting, net power is 300 volt ampere you are getting by using this three-phase variable. Same power you will get by taking two-phase DC signals also. There is no change in net power. Same information, same power we can carry, same information we can carry with less number of control variables if you adopt transformation techniques. That is the main advantage of transformation technique. By using transformation technique, we can easily design the PI controller. Understood? That is the main aim of transformation technique. We can easily estimate. Estimation purpose is secondary, but main object of transformation is decreasing the number of control variables with respect to control software. Right? So here, next one more important thing. So here, this is the three-phase induction machine DQ reference frame model. This is the equivalent circuit diagram of the three-phase induction machine in DQ reference frame. Here in this equivalent circuit diagram you can find in postgraduate courses, but in undergraduate courses in the electrical machine subject, here per phase equivalent circuit diagram you might have seen like this. This is the per phase equivalent circuit diagram of the three-phase induction machine. Now please tell me, what is the basic difference between undergraduate course equivalent circuit diagram and postgraduate level equivalent circuit diagram? Anyone from the audience? This is per phase equivalent circuit diagram of the three-phase induction machine. This Equivalent
The
circuit
rotor
diagram.
coupling is not explained in UG courses. Whatever the rotor linkage with the stator flux linkage, that mutual flux is not that much explained. They will only deal with what we call it as equivalent impedance only. The transformation only they will discuss. Or rotor induced EMF part only they will discuss.
I will tell. In generalized form, I will try to tell. Then only participants will understand this equivalent circuit diagram. Whatever equivalent circuit diagram you have studied in undergraduate course, per phase equivalent circuit diagram, this equivalent circuit diagram is not applicable for dynamic condition. This equivalent circuit diagram we have derived under steady state condition. Based on the steady state operation, here you have obtained this equivalent circuit diagram. Nothing but this equivalent circuit diagram is applicable for only steady state analysis. Under steady state condition, what is the operating speed? Under steady state condition, what is the efficiency of the machine? Under steady state condition, how much torque it will produce? For understanding the steady state behavior, you can adopt this equivalent circuit diagram. This equivalent circuit diagram, it is not applicable for dynamic condition. That's why it is called steady state equivalent circuit diagram. But postgraduate level, this equivalent circuit diagram is applicable for steady state as well as dynamic conditions. By using this equivalent circuit diagram, we can understand how machine is behaving, how current is regulating, if there is any change in the torque, how frequency is regulating, rotor frequency is regulating based on the load torque, how machine speed dynamics are varied with respect to change in input voltage. Each and everything, dynamic operation, we can extract by using this equivalent circuit diagram. The equivalent circuit diagram is applicable for steady state as well as dynamic conditions, right? So by using this equivalent circuit diagram, we can extract the machine behavior, how machine is behaving in steady state as well as dynamic conditions. Both characteristics we can extract by using this equivalent circuit diagram. This is not applicable for dynamic condition. That is the problem with undergraduate equivalent circuit diagram, right? So now come to classification of speed control schemes. Generally, speed control schemes are classified into two parts. One is scalar control method, another one is vector control method. By using scalar control method, we can control the torque based on the average sense. Average torque we can control, but instantaneously we cannot control. Why? Because by using scalar control, we can control the magnitude only. Magnitude of the voltage, magnitude of the frequency, magnitude of the current we can control. We cannot control the position. We cannot control the phase. That is the problem in scalar control. But in case of vector control, we can control the magnitude as well as phase. Direction we can control. If you are able to control the magnitude and direction of the voltage or current vectors, we can control the torque instantaneously. Instantaneous torque control is required in electric vehicle application. But average torque control, it is they are adopting only for low performance track, agriculture purpose, water pumping application. They are using this scalar control. But electric vehicle application, they are preferring instantaneous torque control. Right? In vector control scheme, there are so many methods they have proposed to control the torque instantaneous. But field orientation method and direct torque control method, these two methods become so popular. This is the first method they have proposed under vector control scheme. In 1970s, they have proposed field orientation method. In 1980s, they have proposed direct torque control method. Right? The main aim of field orientation method or direct torque control method or model predictive control, main aim is controlling the torque instantaneously. Right? Here, if you want control the torque instantaneously, as a controller, as a scholar, you need to take care about these 3 points. These 3 points are so important for AC machine controller. So if you want to control the torque instantaneously, first requirement is torque should be in linear mode. Linear nothing but it should be in how many? Linear condition nothing but how many number of state variables are involved in the torque expression? Only one state variable, first order. It should be in first order. How we can achieve the first order? By using these 3 points, we can understand. So in order to get the torque expression with respect to controller in linear mode, you need to take care about these points. First point is you need to take care about the space displacement angle between field flux and armature current. Armature MMF and field MMF, space displacement angle should be 90 degrees electrical. Not you forget about mechanical. Electrically, space displacement angle should be 90 degree. The space displacement between the field flux and armature flux is 90 degree. If armature flux is leads the field flux by 90 degree, then effective current is also, armature MMF is also acting in the same axis. It is mean armature MMF or armature current, because of armature MMF only flux is coming always in phase with breast axis. You can think here, you can analyze where is the effect. In case of DC machine, many of the scholars are getting confused. Where is the effective coil in DC machine? In case of DC machine, armature coil effectively working always in phase. This is the position of the armature coil. Armature coil is always working effectively in phase with breast axis. This is the position. This is called armature effective coil, assumption coil. The function of this coil is it is always try to produce the MMF in phase with breast axis. MMF axis is in phase with breast axis. That's why armature flux direction is also in phase with MMF axis. So field flux is always in phase with pole axis. The space displacement between the field flux and armature flux is always 90 degree. This is happening naturally by nature. By physical structure itself, DC machine will maintain 90 degree. But in case of AC machine, as a controller, you need to take care about the space displacement angle. Forcefully, here you need to maintain 90 degree. How we can maintain 90 degree? By using field orientation concept, I will try to explain. Here, understood? Here in case of DC machine, because of physical structure itself, delta become 90 degrees. But in case of AC machine, here with respect to controller, please try to understand these points are all points. This concept, whatever we are discussing, these concepts are valid only with respect to controller. But practically, naturally, your system is always higher order. It is always nonlinear in nature. Here, by using controller, we can control the nonlinear system very fast by making the controller in linear mode. That is the beauty of this transformation technique. How we can control the students in class? Students always here their mindsets are always in very complex form. As a teacher, you have to clear their concepts. Then automatically complexity will come down. Then you can make your subject more effectively. That is the as a controller we can make. So with respect to controller, we can make space displacement angle 90 degree, right? So this is the first step you have to perform. You have to take care about with respect to controller. Now, once space displacement angle is 90 degree, then advantage is here you can control the field flux or armature flux independently. If you want change the field flux, then you can change. There is no effect on pi a. At the same time, if you want change the pi a, there is no effect on pi a. If space displacement angle is 90 degree, both will control. We can control independently, right? That is the advantage. Space displacement angle is 90 degrees electrical. One more thing is, if here armature current, we can control instantaneously. If space displacement angle is 90 degree, by controlling the armature current instantaneously, there is no effect on field flux. Then number of state variable involved in the torque expression will come down. These three are so important points, particularly if you want to control the torque instantaneous. Instantaneous torque is required in electric vehicle application. Not only electrical application, not only electric vehicle application. Wherever high performance system drives are required, right? There you need to adopt this concept, right? Vector control of an induction machine. What is the main challenging of the vector control? Why people, before proposing this field orientation method, why people they were not motivating towards AC machine? What are the challenges? By using this slide, I will try to highlight. So here, before explain the difficulties in AC drives before invention of field orientation method, what are the advantages of the DC machine? I will try to explain. Then I will try to highlight the DC motor advantages. After that, what are the challenges in AC drives? I will try to explain. After next point is how we can overcome the drawbacks of the AC machines control. I will try to. In case of DC machine, the path for the field winding and path for the armature current, if you take separately excited machine or shunt machine, this is the path for field current. This is the path for armature current. Armature current path and magnetizing current paths are different. This is what is the aim of this one, this component. Aim is controlling the torque, right? Torque is directly proportional to Ia. Condition is you need to maintain field current as a constant. Field current we can maintain constant by using some external DC source. That is the advantage of DC motor. In case of DC machine, based on the required magnetizing flux amplitude, we can adjust the field current. Further, we can maintain constant. Magnetizing flux path, magnetizing flux producing current and torque producing current paths are different. Path, this is the path. Paths are different in case of DC machine. But come to this is the main advantage of the AC DC machine. But in case of DC machine, particularly take induction machine. In case of induction machine, what is the mathematical expression for input current? Input current equal to I0 plus I2 dash. This is the standard mathematical expression. You can find in the textbooks also. What is the function of I0? I0 is nothing but it is having two components. One is core loss component, another one is magnetizing component. You forget about core loss component. So I1 equal to combination of magnetizing component and I2 dash. This is called flux producing component. Flux producing component. What is the function of I2 dash? Anyone? What is the name of I2 dash from the audience?
Secondary equivalent of primary current.
This is called torque producing component. Am I correct or not? If burden is increases, secondary current it will increases. If secondary current it increases, I2 dash also will increases. Am I correct or not? It is reflecting. I2 dash is nothing but secondary current referred to primary side. If there is any secondary current is there, immediately it will reflect on the primary side. That is the main. Where I2 dash is called torque producing component. I mu is called flux producing component. So if you take input current to the three-phase induction machine, IAS, IBS, ICS. So by taking this IAS is nothing but inherently there are two components are there, flux producing component as well as torque producing component. Similarly, even if you take IBS also, there are two components are there. There are two current components are involved in the IBS, IAS as well as ICS. Now you can think, what is the advantage of DC motor? Field current and flux producing component and torque producing components paths are separate. Both electrical paths are isolated. But in case of AC machine, induction machine, particularly in case of induction machine, there is no option. We don't have any separate path for flux producing current as well as torque producing current. Both currents are flowing through the stator winding only. This is the big challenge. If you want control the magnetizing current, you need to take care about the input current. At the same time, if you want control the torque, you need to take care about the overall input current. Right? Overall, depends on the requirement, depends on the situation. By taking these three-phase currents, IAS, IBS, ICS, we cannot control the magnetizing current as well as torque control component separately. That is the problem with AC drives. Why? Because by taking these three-phase currents, we can produce the flux component and we can produce the torque producing currents as well as flux producing currents we can produce. But problem is by controlling, you have to face the problem. Why? Because there is no separate path for the magnetizing current. There is no separate path for the torque producing current. Torque producing current as well as flux producing current, both currents are flowing in the same path. That is the main problem in AC drives. In order to overcome this problem, in order to separate the flux producing current, torque producing current for the three-phase AC system, in 1970s, they have proposed field orientation method. By using this field orientation method, the main aim of field orientation method is, first job is they will try to separate this. They will try to separate the flux producing component and torque producing component from this three-phase current. First, they will try to take these three-phase currents from the three-phase currents. What they will do, they will apply transformation techniques. By using current sensors, they will sense the terminal currents, IA, IB, ICS currents they will sense. After that, they will adopt transformation techniques. By using transformation technique, immediately what will happen? Here, your three-phase variables will converted to two-phase variables. So, one current. So, at any instant of the time, after adopting this transformation technique, what is the space displacement angle? Here, at any instant of the time, here, if you observe the space displacement in two-phase transformation, the space displacement angle between the alpha and beta after applying the Clark transformation or after applying the Park transformation, the space displacement angle between the D and Q vectors is always 90 degrees. So here the mathematical expressions, transformation mathematical expression itself will separate the two-phase currents into 90 degree with 90 degree electrical space displacement. So one is called d-axis current, another one is q-axis current. So finally, what will happen in case of FOC method, to get the clarity among these three-phase current, how much field flux we need to control, how much torque producing current we need to supply to the machine. In order to get the clarity, first step is they will try to adopt transformation technique. After applying the transformation technique, what benefit you will get as a controller? What benefit you will get? You will get independent. You will get complete information. You will get three-phase currents will converted to two-phase currents. So by next one more thing is this two-phase current space displacement angle is 90 degree. Then what is the benefit? You can assign this ID as a flux producing. Practically what they are doing, generally ID they will assign for flux producing component, IQ they will assign for torque producing component. That's why please start understand. If you take any drive, whether it is a field orientation method or direct torque control method or modified control method, control variables are only two. In case of electric drive system, we are having only two control variables. One is torque, another one is flux. What is the benefit if you take flux as a control variable? Is we can reduce the number of control variables in the torque expression. If number of control variables in the torque expression will come down, advantage is here your torque equation become lower order. Linear equation you will get. That is the benefit you will get if you take flux as one of the control variable in electrical drive system. Right? Now come to, so by taking this phasor diagram, I will try to explain what is the benefit of this transformation technique, what is field orientation method, I will try to explain. Here already we have discussed the torque is in 7th order for induction machine. If you take the 7th order expression, so this 7th order expression will become 4th order after applying the transformation techniques. Pre-transformation. Simply by applying the transformation technique, don't think your torque equation become linear. Don't think it is coming in first order. Even if you apply transformation technique, even if you apply two-phase transformation technique, you will not get linear expression. You will get still your torque expression is in non-linear. It is in 4th order equation. Right? This 4th order expression involved rotor flux is involved, stator current is involved. This is the resultant rotor flux. This resultant rotor flux we can resolve by using natural currents, A phase, B phase, C phase currents. Flux we can take natural A phase, B phase, C phase flux. Whatever amplitude and vector you are getting, same vector we can realize by using Q axis and D axis flux linkage. Similarly, the resultant stator current, natural current, actual current vector we can realize by using two-phase components also. Whatever information you are getting by using three-phase variables, same information you will get by taking two-phase variables also. Similarly, stator current also we can realize by taking two-phase D-axis and P-axis current. This is the phasor diagram of the three-phase induction machine in DQ reference frame before applying FOC. Before applying FOC, this is the phasor diagram. After applying FOC, then what is happening? This is after applying field orientation. Still we have not applied FOC. Then your torque is in nonlinear condition. But what is our requirement? Our requirement is torque should be in first order with respect to controller. Right? So in FOC, what they will do here, this is D and Q axis vectors field we can control. right? So in practically, they will sense the rotor flux position. What is the theta e? They will position with respect to this theta e. They will rotate the d-axis forcefully. This is the axis of rotor flux vector. This is the axis. Forcefully d-axis they will bring in phase with rotor flux vector. Once d-axis is coming in phase with rotor flux vector, then the effect of q-axis component, the effect of this component becomes 0. Once lambda qr is 0 in this expression, then what will happen? Lambda qr is 0 in fourth order expression, then your torque equation becomes second order equation. After that, you need to adopt armature control method. You need to apply V by F method. By using V by F method, we can maintain lambda dr, area flux, magnitude we can maintain constant. If it is a constant, then your torque is directly proportional to only q-axis current. By regulating the q-axis current, we can control the torque. This is the beauty. This is the main aim of field orientation method. Please try to understand. Simply by applying the transformation, don't think your torque equation becomes linear. It will not. After adopting the field orientation method, after bringing the field orientation method, FOC full form is field orientation control. Nothing but they are trying to bring the d-axis in phase with rotor flux vector. They are trying to orient, bring the d-axis. Once reference d-axis is bringing in phase with rotor flux vector, mathematically the effect of q-axis component becomes 0. This is mathematical proof is there. So once lambda qr is 0, okay, with respect to controller, then your torque equation becomes second order. Finally, what is happening? After applying the FOC, your seventh order equation becomes second order. Next, further, you need to apply flux control. You need to maintain field flux as a constant. How we can maintain field flux as a constant? You need to adopt V by F method. By using V by F method, we can maintain lambda dr as a constant. Then torque is depends on only IQS. By regulating the IQS, we can control the torque instantaneously. This is the way of controlling the torque instantaneously by using field orientation method. Without taking the transformation technique, without applying the field orientation with combination of transformation technique, we can bring the seventh order equation to first order with respect to control circuit. Once by controlling the IQS more effectively based on the customer requirement, within short period, instantaneously we can control the torque, right? So finally, it is in first order. What AC motor, induction machine torque is in first order with respect to controller. Whatever torque profile you are getting in case of induction machine, if you verify with the DC motor torque profile and AC motor induction machine torque profile, both are coming similar. Finally, for all machines, generally DC motors are called reference machines, standard machines. With respect to torque profile, it is very strong. That's why while evaluating the torque profile of a particular machine, they will try to verify the results with the DC motor torque profile. So DC motor torque profile and induction machine torque profile are coming close to each other after adopting FOC method. By using FOC, we can improve the torque profile of the AC motors, right? Right. Similarly, in 1980s, they have proposed direct torque control method. By using this method also, we can control the torque instantaneously. Okay. Now, almost what is time? Shall I take 5 minutes extra to the participants? Shall I take?
Yes, sir, you can.
If
Yes, sir, you can.
you allows, I will take. Otherwise, I will try to wind up today's session. Can I take 5 minutes extra?
Yes, sir, you can, sir.
Yes, sir, you can take, sir.
Yeah, thank you. Now come to this method. By using this method, we can control the torque as well as flux directly. But in case of previous method, what we did, we are trying to control the flux by using IDS component. We can control the torque by using IQS component. This is called basically field orientation method. It is a current control method. But this one, direct torque control method, it is called voltage control method. By choosing the proper voltage vector, we can control the flux as well as torque. That's why it is called direct torque as well as direct flux control method. So here, these all the converter methods are available in literature. Depends on requirement, depends on situation. You can adopt these methods. These are all the various controllers. Hysteresis controllers are available in literature. Linear controllers also available. Sliding mode controllers are also available. Predictive controllers are available. Artificial intelligence controllers also available. Generally, hysteresis controller, they are adopting in direct power control method. This is for drives application. Direct power control method. This is for grid connected inverters. They are adopting direct power. DPC, nothing but direct power control method. Now come to linear controllers. Generally, linear controllers, they are adopting in field orientation control and voltage orientation control. This is for grid connected inverters. They are adopting voltage orientation control, field orientation control. Generally, they are adopting for drives application. Sliding mode controllers, their current controllers, voltage controllers are there. Come to predictive, dead bit control, model predictive, generalized predictive. Compared to other methods, predictive control method becomes so popular in drives application. Yes, fuzzy logic, neural network, neurofuzzy, these methods they are adopting in domestic application, washing machines, fridge, ACs, they are adopting, AC drive, motor drive control, they are adopting this one. Okay, for electric vehicle applications, they are using, still they are using conventional methods as well as model predictive control methods they are adopting. Field orientation method, direct power control and model predictive control method, they are trying to adopt in electric vehicle application to control the torque instantaneously by using these methods, by using field orientation method, direct torque control method, as well as model predictive control method. They are trying to control the torque instantaneously. With respect to controller, they are trying to bring the torque expression into linear mode. Once your torque is linear with respect to controller, we can improve the torque profile of the AC machine similar to DC machine. That is the beauty of this control scheme. In today's session, I will try to highlight what is model predictive control, why it is so important for drives application. Only key points I will try to highlight. After that, within 5 minutes, I will try to wind up today's session. Right now, come to applications of model predictive control method. Generally, this for various applications. Model predictive control method, it is not only applicable for electric vehicle application, they are adopting for chemical factories, power system application, aerospace application, renewable energy, domestic applications also they are trying to adopt this model predictive control method. Why this method became so popular nowadays? So here, so predictive control method, why they are adopting particularly nowadays? Why it doesn't not become popular earlier? So by using this slide, we can understand what is the nature of power converters and drives available. This is the characteristics of the power converters and drives. This is the characteristics of the controllers of the present days. In present days, what is the nature of control system? Right? This is the control circuit. This is called power circuit. With respect to power circuits, there are two parts are there. One is power electronic module and motor is there. So now first we'll try to discuss power converter and drives characteristics. Basically, your power converter as well as drive, basically it is a non-linear system. Next, with respect to power electronic module, there are limited number of switching states are available with respect to your power electronic module. At the same time, you need to take care of what the constraints, whether switching frequency is within the zone or not, that you have to take care. These are all the available characteristics of the power electronic module as well as drives. Now come to control circuit. With respect to control circuit, nowadays no one is using analog circuit. Everyone is using digital circuit, nothing but discrete time implementation. This is the nature, this is the characteristics of the available control system. Next, at the same time, as a controller, you should know the model of the power converters and drive. Model is nothing but mathematical representation of the actual system. So motor as well as power electronic module. How many switching states are available with respect to power electronic module? Here, if you take three-phase, two-level voltage source inverter, 8 switching states are possible, right? This information here you should know. At the same time, what type of motor you are using, what is the model of the mathematical model of the equation for the particular system. Each and everything you should know. Once you know the motor model, at the same time information of the power electronic module switches, then we can develop the predictive control. In order to develop the predictive control, main aim is you should know the mathematical model of the motor. At the same time, you should know how many switching states are available with respect to power electronic model. Once you know the motor model and switching states of the power electronic model, by using the power circuit characteristics as well as control circuit characteristics, we can easily implement the predictive control scheme, right? So by using, what is the main difference between the predictive and PID controller? PID controller, if you take PI controller, so generally, even if you take predictive control or PID controller, conventional PI controller, what is the input? Error is input. Output is modulating signal. By using PI controller, the main drawback of PI controller, it will handle only one input signal and it will produce only one output signal. It is not for multi-inputs and multi-output system, PI controller. That is the main drawback. But if you take model predictive controller, we can take n number of inputs, n number of control variables we can take, and n number of switching, then n number of outputs we can produce by using model predictive control technique. This is the main difference between conventional method and model predictive control method. Yeah, if you want to develop your control mechanism using model predictive control method, main requirement is you should have mathematical model of your actual system. Without knowing the mathematical model of the actual system, we cannot develop the model predictive control method. Okay, now in this session, I don't have time to explain in depth of the model predictive control scheme. Yeah, if possible, you can go through the papers, you can understand. It is not so easy to understand. Only thing is, what is the requirement? When model predictive control scheme equations, cost function equations, it will vary system to system. Based on customer requirement, also number of control variables will vary. That's why you need to go through the standard textbooks as well as standard papers. First, you try to understand the objectives of the particular paper. After that, how they have decided control variables, you have to understand. Then how they will implement. By doing practice, you will get. Okay. So the main advantage of the model predictive control is, finally you can verify. First waveform is related to speed torque characteristics using direct torque control method. Second waveform is speed torque profile using model predictive control method. What is the difference? In both cases, there is no change in the steady state speed as well as average torque. In both cases, same only. Only thing is, compared to torque second waveform, this waveform, this one, this is the torque profile, steady state torque. This one speed omega r, this is the torque. In both cases, omega r is same, but come to torque, generated torque contain more ripples in direct torque control. But in case of predictive method, the main aim is steady state profile, it will improve. That is the main object of model predictive. By using model predictive, here we cannot improve the dynamic response. Here we cannot improve this profile, torque profile. In both cases, it will give same response. Only thing is steady state response we can improve by using predictive control method. Okay, so by using direct torque control method or predictive method, okay, or vector control method, field orientation method, any method, finally they are taking torque and flux as a control variable. Right? This in today's session, what we understood, how why people are motivating towards electric motor and vehicle application, how we can select the control variables, what are the types of electric motors they are adopting in vehicle application, we have discussed. At the same time, what are the speed control methods for AC drives, we have discussed. This method, predictive torque control method, is advanced control schemes. There is a lot of research is going on this topic. You can find n number of papers, new papers in recent days. Okay. Here, if you want, there is a lot of scope is there. This model predictive control method you can adopt in power quality issues, grid connected inverters. You can adopt. Okay. Thank you. If you have any doubt, you can ask. After that, I will try to wind up today's session.
Sir, one of the participant is asking the mathematical correlation between Clark and Park transmission.
Clark and Park.
Yes.
Yeah. Here, please shut down. Here, the aim of Clark transformation is different. The aim of Path transformation is different. By using clock transformation, we can convert three-phase variables, natural variables, into two-phase stationary form. Stationary form is nothing but after converting three-phase variables to two-phase variables, finally two-phase variables are in AC nature. That is the main object of clock transformation technique. If you take path transformation technique, in case of path transformation technique, what they will do, two-phase AC signals, they will convert it to two-phase DC signals. Clear? Objective is different. Applications are different. Generally, with respect to controller, particularly in our case, drives application, they are using cross transformation technique. Directly, they will adopt cross transformation technique. The advantage of cross transformation is directly three-phase variables, AC variables, we can convert it to two-phase DC variables. That is the advantage of cross transformation. Park is before invention of cross transformation technique, you need to adopt clock transformation technique. After that, you have to apply path transformation technique. After using this two transformation technique, what will happen? Your three-phase AC variables will convert it to two-phase DC. So to reduce the mathematical complexity, to reduce the number of steps to get the two-phase DC variables, they have proposed cross transformation technique. Understood? Clear?
Yes, sir. Sir, another query. How can we make a combined controller using MPC and fuzzy or neural network?
No. We cannot. Why? Because by using the main motive towards model predictive is by using model predictive, advantages depends on requirement. You can take more number of control variables. Suppose here I will tell here generalized applications. I will try to highlight, then you can understand. See here. So here, if you want to adopt this model predictive control method in UPS application, voltage control of UPS application, switching frequency of voltage converters. Here, further, if you want to reduce the common mode voltage, or if you want to control the reactive power in grid connected inverters, here more number of control variables you can write in a single equation, that is the cost function. In case of model predictive control method, there is only one expression is there in, with respect to controller. That is called cost function. In cost function, here they will try to calculate the error. Now here generally, particularly in the electrical drives, they are trying to calculate the torque error as well as flux error. Why? Because torque and flux are the control variables. In cost function, by using cost function, they will calculate torque error and flux error. Anyway, by using single cost function, we are able to control the machine. Why unnecessarily taking another controller, fuzzy logic and another controller? No need. It doesn't require for this application. Right? Fine.
Yes, sir. Another one more question. Is there any toolbox to implement MPC in MATLAB 2021A?
Here I'm telling, as a scholar, you should not depend on the toolbox. My request is, while learning the concept, you have to depend on the model. You have to develop the mathematical expression for the particular system. Particular machine modeling you have to develop. At the same time, particular model predictive control, there is no particular toolbox. Why? Because your system is varied, your load is varied, then cost function control variables also will vary. In that case, very difficult to take the inbuilt toolbox. My request is you need to design the controller based on your system requirement, right? Fine.
Okay, sir.
Yeah, thank you. Shall I stop
Okay,
here?
sir. Yeah, yes, sir. Yes, sir. Yes, sir.
Thank you.
Thank you, sir. Thank you very much. Thank you very much for giving a valuable information regarding the suitable electric motor suitable electric motors, which is chosen for electric vehicle applications and their mathematical analysis also. Thank you, sir. Thank you very much.
Yeah, thank you.
Thank you, sir, Vinay, sir.
Okay, thank you, sir.
Thank you, sir. Thank you for your valuable time.
Thank you, madam. Thank you.
Participants, tomorrow's session will start exactly at 10 a.m. Thank you all.